Welcome everyone to the Fire and Grazing on Rangelands virtual workshop. I really appreciate you being here today. My name is Devii Rao. I'm the Livestock and Natural Resources Advisor with UC Cooperative Extension in San Benito, Monterey, and Santa Cruz counties, and I will be facilitating the webinar today. Before we get started, I wanted to go over some logistics. This will be a 1-hour webinar, and the webinar is being recorded and it will be available online. A lot of people registered for the workshop, so to keep the noise down, everyone was automatically muted when they entered the meeting. There will be a couple of opportunities for questions and comments during the call today, so you can unmute yourself at that time to ask questions. You can also use the chat box for questions, and if there's anyone who called in with just a telephone, if you have a question, you can unmute yourself by pressing *6 and then press *6 again to remute yourself after you've asked your question. During the first portion of this webinar, Felix Radcliffe will share preliminary results from a study looking at greenhouse gas emissions and particulate matter from grassland sites that were grazed and then went on to burn in wildfire compared to those that were not grazed and went on to burn. And this study was funded by the California Cattle Council. During the remainder of the hour, we will discuss recent activities of the newly formed Central Coast Prescribed Burn Association, which was developed through a CAL FIRE fire prevention grant. So let's go ahead and get started. And like I said, our first speaker is Felix Radcliffe. He is with LD Ford Consultants in Rangeland Conservation Science. Felix, go ahead and take it away.
All right, hello everybody. I'm gonna share my screen, so 1 second. Here we go. That should do it. Can everybody see that? Any thumbs up? Okay, I see some nods.
That's good.
Good, excellent, thanks. Okay, so great. Thanks a lot, Davey. My name is Felix Radcliffe. I work for LD Ford Consultants in Rangeland Conservation Science. And I'll be talking to you today about some work that I've been doing with some co-investigators, including Davey and others at UC ANR, also at UC Berkeley and UC Davis. And we've been working on a project to try to answer the question, if you take a grassland that burns in a wildfire, does cattle grazing reduce the amount of emissions of greenhouse gases and particulate matter from that grassland, once you consider also the emissions that come from grazing? And if so, by how much, right? So how much can you impact the amount of emissions that come out of wildfires by grazing those grasslands before they burn? I'm also going to talk a little bit about some updates from some other research that we've done that looks at how cattle grazing impacts wildfire behavior in grasslands. All right, so we started by looking at some USDA Ag Census data and some California brand inspection data to figure out about how much beef cattle grazing is occurring in different parts of the state, different regions of the state. And the reason that we did this is we wanted to get an estimate of how much forage was being removed from these various areas of the state through cattle grazing. And we wanted to know that because we wanted to get an estimate of about how much fuel is then being removed from grasslands and from other rangelands in the state. The answer that we came up with was it's highly variable by region, and that's what this graph here shows. I don't know if you can see my cursor here, but all these different bars are showing millions of pounds of forage that was removed from each one of these regions. So it's highly variable due to a lot of different variables, a lot of different factors, but in total, across the whole state, about 11.6 billion, with a B, billion pounds of forage or potential wildfire fuel, if you want to look at it that way, is being removed by cattle. And this was specifically in 2017, but there's no reason to believe that it's really any different from other years. All right, so I want to put that 11.6 billion pounds of forage or fuel being removed into context. The California Air Resources Board, who produced this graph that's now on the slide, recently estimated about how much carbon is transformed through forestry practices every year. So this is carbon that is transformed in one way or another through things like timber harvest, thinning, prescribed burning, and mastication and other mechanical treatments. And what they estimated is that on average, over almost the last 20 years, about 4.6 million metric tons of carbon are transformed every year through forestry practices. So just for a little bit of context and reference, 1 million metric tons is about 2.2 billion pounds. I'm going to be referring to million metric tons, or MMTs. You'll see that in some of these graphs. So it's a big number, right? So 4.6 million metric tons of carbon are transformed in one way or another by various forestry practices in the state. Now, our estimate of carbon consumed, that 11.6 billion pounds, after you've sort of accounted for how much of that forage is actually carbon and done some various unit transformations, what we come up with is it's about 2.4 million metric tons of carbon that are transformed by cattle grazing on rangelands in California, by our estimate. So that's a little bit more than half of that forestry number, right, of that 4.6 million metric tons. And it turns out that's a really big amount. The 2.4 that we see transformed on rangelands is huge when you consider that only 8% of the above ground carbon, of the above ground biomass in ecosystems in California, only about 8% is in grasslands and shrublands in various rangeland community types. And about 92% of the above ground biomass, or the above ground carbon, is in forests. So we're taking the system that has a relatively small amount of the carbon and actually doing a lot of cycling of that carbon, a lot of transformation of that carbon through management with grazing. So if grazing is altering a substantial amount, which it is, of above ground biomass, then it stands to reason that it has the potential to affect fuel loads on grasslands and on rangelands generally, and therefore affect wildfire characteristics, including emissions. All right, so I probably don't need to say this. You all are probably all aware that wildfires have been burning more and more acreage in California every year, right? This graph on the left is showing millions of acres burned in wildfires in California every year, starting at 1990 and going all the way up through 2020. You can see there that 2020, which is this dot on the graph, has, by far the largest area burned actually in recorded history. And it had about 4.2 million acres burned over the course of the year. This graph on the right shows that over the course of recorded history, which is, say, give or take about a century, 17 of the 20 largest wildfires recorded in the state have occurred just in the last 20 years. And so what that means is not only are we seeing more acreage burn every year, but also we're seeing, in general, some of the larger and larger fires as well. All right, this increase in acres burned has also been true when looking at grassland acres. So in 2020, which is this dot on this graph up here, about 350,000 acres of grassland burned in the state. And on average, if you look over the last 10 years, about 90,000 acres have burned annually in California. So every year we're seeing about 90,000 acres of grassland burn. Okay, so these fires, of course, tragically, they threaten structures, landscapes, livelihoods, and even lives. And in addition to all of that, they also emit a lot of gases and a lot of particulate matter. While CO2 is the major gas released by far from wildfires, wildfires also release a lot of other gases, things like methane and carbon monoxide, and importantly, black carbon, particulate matter. So these emissions, these other emissions that are not CO2, can have a much bigger impact, sort of pound for pound, than CO2 when thinking about global warming. So for example, when you look over a 100-year time period, a pound of methane has the equivalent sort of warming potential or warming capacity as about 28 pounds of carbon dioxide. So it's much more potent as a greenhouse gas. And even more sort of strikingly, I guess, or amazingly, a pound of black carbon is the equivalent of about 900 pounds of carbon dioxide. Although I will sort of caution that it's important to note with this black carbon number, it's way bigger, the global warming potential is way more than carbon dioxide, but it's also highly variable. So the IPCC gives a range of global warming potential for black carbon of anywhere between about 100 and 1700. So that 900 value is right in the middle of that range. And so there's still some uncertainty there that needs to be worked out. In our study, we used a measure called CO2 equivalence, or CO2e, to standardize the warming impact of these different emissions. So CO2e takes into account that warming potential of these different gases, averaged over a time span, in this case, 100 years. And what it does is it allows us to compare sort of apples to apples, I guess, if you will, the different emissions types. So like methane compared to carbon dioxide, to have a standardized unit that we can use for comparison. And when building this kind of thing, we pretty much based it directly on those global warming potentials. So for example, 1 pound of methane would be equal to 28 pounds of CO2e, if that makes sense. All right, so in addition to greenhouse gases, fires are also release a lot of smoke, right? And one component of smoke is fine particulate matter. We refer to this as PM 2.5. So if you're familiar with air quality maps, like the one shown here on the right, these air quality indexes that are used to build these maps take into consideration more than just PM 2.5, but PM 2.5 is a major contributor to poor air quality. And we know that this can have really adverse health impacts for people who live with this air quality, as probably many people on the call right now are. So this is a major downside, of course, of wildfires. So we were curious, if cattle are removing about 11.6 billion pounds of forage and potential fuel from rangelands in California every year, how much does that removal of forage impact the emissions of greenhouse gases and particulate matter from wildfires, especially considering that on average about 90,000 acres of grassland are burning every year? So in order to consider this from the greenhouse gas perspective, we also have to think about what's being emitted by the cattle, right? We know that cattle grazing has its own greenhouse gas emissions, mostly in the form of methane from enteric fermentation or microbial activity in the rumen, but also some nitrous oxide and methane from nitrogen and carbon excreted in manure. So what we did is we made a model that calculates if a grazed grassland is burned, are the reductions that we see from wildfire emissions due to that grazing, due to that fuel being removed by grazing, are those reductions greater than the additional greenhouse gas emissions from the digestion of that fuel, right? From the actual removal of that grazing by cattle. And how much does cattle grazing reduce particulate matter emissions from grassland wildfires? And here's what we found. So we found that if you take a grassland that burns in a given year, the greenhouse gas emissions from that grassland are less if it's grazed before it burns, even after you take into account the emissions due to grazing, right? The emissions from the cattle. And this figure here shows how much reduction in greenhouse gases we estimated occurred each year over the last 10 years due to cattle grazing in grasslands that went on to burn. And these shaded areas here show what the uncertainty around our estimate were. I will say a lot of that uncertainty actually hinges on the fact that we had these variable black carbon numbers. There's a lot of uncertainty around black carbon. So it's important to note that while cattle grazing appears to reduce the total amount of greenhouse gases emitted on grasslands that then go on to burn, the magnitude of those reductions of emissions, the magnitude of the reductions in greenhouse gas emissions is pretty small. And so, for example, CARB, the California Air Resources Board, estimated that in 2020, approximately 2.1 million metric tons of CO2, of carbon dioxide, was released from wildfires in grasslands in California. We estimated in 2020, you can see it here on this graph on the far right, that about 0.02 million metric tons of CO2 equivalents were avoided in burned grasslands due to cattle grazing in those grasslands. So the total amount of avoided emissions was only about 1% of the total grassland wildfire CO2 emissions. And it's important to note actually that those CARB numbers, those CO2 emissions, are just CO2. It doesn't take into account all the other potential global greenhouse gases, excuse me. And so actually it's arguably less than 1% of the total greenhouse gas emissions from just the grassland fires in California in that same year. Now, there is also a reduction in particulate emissions in grasslands that go on to burn, thanks to grazing in those grasslands. And these reductions are also similarly fairly small when compared to the total emissions from wildfires in grasslands in California. Reductions in PM 2.5 due to grazing were about 6% of the total estimated PM 2.5 emissions from wildfires and grasslands in 2020. So 6% is a lot bigger than 1% or a little bit less than 1%, like we saw with greenhouse gases. And the main reason that we see that difference is because in the situation where you have cattle grazing and you're looking at how much greenhouse gases are reduced, those cattle are also producing greenhouse gases, right? So that limits the amount of reduction of greenhouse gases. Well, in the case of particulate matter, those cattle are not producing particulate matter. And so any reductions that we see due to cattle grazing are just pure reductions. It's just a net reduction. There's no balancing due to particulate matter created by cattle, because there really isn't any. So those last charts, we're looking at reductions in greenhouse gases and particulate matter due to fuel reductions from grazing, removal of herbaceous forage, of the food that they eat on a year-to-year basis, right? So forage removal is a process that happens every year. But we know that grazing and other ranching practices can affect landscapes and vegetation on these landscapes over longer periods of time as well. It's not just what herbaceous forage is removed within a year, but there can be long-term changes. And one example of this is that grazing can slow or stop or even stop the encroachment of shrubs into grasslands. And this has been especially well documented in more coastal areas of the state, so in the central coast and northern coast areas of the state. Where if a grassland is left ungrazed, and generally speaking, if there's also fire suppression at the same time, shrubs like coyote bush can pretty readily invade a lot of grasslands and change it over time into a shrubland. Now, this might be a decadal or multi-decadal process, but over longer periods of time, you can see grasslands transition into shrublands. And this, of course, can have big impacts on fuel loads and thus fire emissions. So to get a sense of sort of what the order of magnitude is of these long-term effects on emissions from grasslands, we took a look at how fire emissions from a couple different shrub types, northern coastal scrub and coastal sage scrub, compared to those from grazed grasslands. So we wanted to know how much emissions come from these shrub systems and how does that compare to grassland systems, right? And what we found is that the difference is a lot bigger, right? Like we're talking about a magnitude that is much bigger than just 0.02 million metric tons across the state. So what we found is that, and if you look at this bottom graph, that's actually a little bit more relevant to what I'll be talking about. This bottom graph is showing the difference in emissions from shrub types compared to grassland types. And what we found is that anywhere between about a third and about 1 million metric tons more CO2 equivalents, you could think of just more greenhouse gases, would have been emitted by wildfires in central and north coast regions of the state if grasslands in those regions that burned in 2020, so if we took the grasslands in the central and the north coast regions of the state that burned in 2020, if those had instead been shrublands, then anywhere between about a third and about 1 more million metric tons of CO2 equivalents would have been released by fires burning those areas. So this is a much bigger number than what we see from just reductions in herbaceous fuel alone. And therefore, preventing grasslands, in the central and north coast regions that burned in 2020 from becoming shrublands potentially has anywhere between about 35 and 90 times more greenhouse gas benefit when thinking about emissions from wildfires than just the avoided emissions due to annual grazing that we saw in that same year. Now, I have to give a couple caveats with this analysis. First thing is this analysis almost certainly overestimates these extra emissions. And that's because we're assuming that 100% of these grassland areas would have transitioned into shrub areas. And we know in reality that that's not really the case, that in reality, some grassland areas, if left ungrazed, might become shrublands, others wouldn't, right? And one other caveat I want to give is that, this isn't the same as saying that shrub encroachment would lead to more global warming, because those shrubs that are out there are also storing carbon before they burn, right? And so before they burn, they're having a bit of a net cooling effect, right? If they never burned, they would just be storing carbon from the atmosphere, which would be great. But depending on shrub encroachment rates, fire return intervals, the emissions associated with livestock grazing on these areas, there could either be sort of a net benefit or a net detriment from a greenhouse gas standpoint of thinking about these shrublands of grasslands converting into shrublands. Nevertheless, because the magnitude is much bigger than just thinking about grassland management, this is an area that needs more work so that we understand it better. Now, just briefly, preventing shrub encroachment in these same regions can also lead to big reductions in particulate matter emissions from wildfires. So unlike greenhouse gas emissions, where there's that question of, well, maybe it's a benefit, maybe it's not a benefit because the carbon's being stored in the shrubs. Well, that doesn't really happen with particulate emissions. In the case of particulate emissions, those shrubs aren't mitigating any particulates. They're not storing particulate matter, but they will release a lot when they burn. And so in that sense, keeping grasslands from becoming shrublands can potentially have a really big impact and really just a net benefit when it comes to thinking about particulate emissions. All right, so everything we were just talking about, particulate matter and greenhouse gas emissions, these are impacts that affect regional, statewide, or even global scales, right, when you think about climate. But reducing fuels has big implications for the way grassland fires behave as well, right? And this has very local or sort of immediate impacts for these fires themselves. So I want to give just a brief update on some of the results from a previous study that we worked on that looked at how grazing altered fuel loads on California rangelands and what that meant for fire behavior. So in this previous study, we found that in non-federal lands, and the picture is very different in federal lands, but in non-federal lands, average stocking rates on grazed rangelands were somewhere around 0.73 AUMs per acre. And so if we translate that into how many pounds of forage that equals, like how much forage is actually removed by that grazing, it's somewhere in the ballpark of about 700 pounds of forage on average being removed from non-federal grazed rangelands. I will just say briefly that in federal rangelands, the stocking rates are much, much lower. So more like about 0.14 animal unit months per acre, or you might think about, 140 pounds per acre of forage removal. And that's for a host of reasons that we don't need to get into right now. But this reduction, say, let's take the 700 pounds per acre of forage reduction that we see on non-federal lands. This reduction can impact fire behavior. So we took a look at this. So one important aspect of fire behavior is flame length. Generally speaking, if flame lengths are less than 4 feet and firefighting crews can fight fires by hand on the ground, and if they're less than 8 feet, they can use machinery on the ground to fight fires. If flame lengths are greater than 8 feet, then these direct measures like the hand fighting fires or using machinery to fight fires are really not an option. So we worked with some fire modelers from UC Santa Barbara who looked at how different combinations of fuel, topography, and weather conditions affect fire behavior. And what we found was if you can keep your grassland fuel load to about 700 to 800 pounds per acre, then in dry fuel conditions on flat slopes, you should be able to keep flame lengths below that 8-foot threshold in a wildfire. Now, in wetter conditions or at lower wind speeds, flame lengths will perhaps even be below 4 feet in some conditions. However, and this is an important caveat to this whole thing, if you have these dry conditions and you also have high wind speeds, say wind speeds above 15 miles per hour, so think sort of like red flag warning conditions, then you would have to graze it down to anywhere between 100 to 400 pounds per acre to keep flame heights below 8 feet. And you can pretty much forget about keeping them below 4 feet. So when you have these extreme fire conditions, it's going to be hard to manage fuels down low enough using grazing alone that you can really, get sort of qualitatively better fire conditions. And that's what this graph, I should have mentioned this in the beginning here, but these, the x-axis on this graph here is wind speed and the y-axis here is fuel load. And these lines, these contour lines here represent different flame heights. So what I'm saying is if you can see my cursor here, this is about where the 700 to 800 pounds per acre comes in. If you can keep fuel loads below this, then at wind speeds below 15 miles an hour, you can, generally speaking, keep your flame lengths below 8 feet. But again, once you get into these high wind speed situations, flame lengths can get really high, even with relatively small fuel loads, ones that you might not want to attempt, either because they're logistically infeasible or because they might have some other detrimental values to them. All right, so that last graph was for low slope areas, and this graph here shows the same thing, but for high slope areas. So this graph is showing what would happen, what the models predict would happen on areas of 100% slope, or say 45-degree slope. So here you can see that you would need to graze grasslands, let's see, down to about 500 pounds per acre or less in order to keep flame heights, again, below that 8-foot threshold. Excuse me. So that's really not ideal for thinking about like managing residual dry matter, right? Because when you get on these really steep slopes, generally speaking, you want to have higher RDM, higher residual dry matter, rather than lower residual dry matter, to make sure you guard against, problems like erosion and things like that. So generally speaking, on these high slopes, you might actually want to keep anywhere between 800 pounds or 1,200 pounds per acre in order to meet minimum RDM recommendations. And so achieving something, down as low as 500 pounds per acre could be really difficult. And then again, or just inadvisable perhaps. Then again, also in extreme weather conditions, when you have wind speeds above 15 miles an hour, you would have to reduce fuel loads anywhere between, say, 100 and 300 pounds per acre in order to, somewhat reliably keep flame lengths below 8 feet. And that could really lead to, a lot of bad situations like bad erosion and things like that. So, managing for these fuel levels on slopes presents some unique challenges. But what's this mean for cattle grazing and wildfire risk? Well, what we saw is that, looking across the state, in general, on non-federal lands, fuels on average are reduced about, say, 700 pounds per acre in grazed rangelands. And that 700 pounds per acre probably is not enough to tip most rangelands into sort of a categorically lower fire risk category or a better fire behavior category. It's probably not going to get most rangelands down, to the point where you're seeing flame lengths below 8 feet. And so I guess you could say, current grazing in the state does not reduce fuels across all rangelands enough to bring all rangelands down to ideal levels. But cattle grazing doesn't reduce all fuels on grazed rangelands evenly, right? It's not a homogeneous process. Many places on grazed rangelands don't get much use at all. And in many other places, fuels are reduced low enough to potentially change wildfire behavior. So, for example, you might have areas of a given ranch that look something like this, right? Where fuel loads might be close to about 500 pounds per acre. And this might be in areas, say, in holding areas for cattle, or areas near residences or structures, areas where fire breaks are being maintained, for example. And this could categorically change fire behavior in most conditions, right? Especially in those non-extreme conditions.
1 minute, Felix.
Okay, thank you. There also might be areas, that get grazed down and look more like this, about, say, 800 pounds per acre. And these would be areas with decent access, but maybe a little bit further out. There might be areas that look about like this, 1,500 pounds per acre. And there might be areas that are just really woolly and look like this, right? Say about more than 4,000 pounds per acre. The point in all this is that many grazed rangelands, do achieve fuel reductions that are useful for reducing flame lengths below 8 feet. And in some cases, even 4 feet during the fire season, and in particular in non-extreme fire weather. But not all grazed rangelands are going to get down to the ideal place, right? So what it means is that it's important to think about, where can we strategically use grazing? Where can we strategically implement grazing to keep grass low along roads, near structures, adjacent to urban developed areas, or other important strategic areas, to maximize the benefit of wildfire safety. And we now know that if a fire does come through a grazed rangeland, this grazing will also have reduced the amount of greenhouse gases and particulate matter that are released by that wildfire that burns through there. So that has local and global benefit, really, for all of us. It may be a small benefit, but it's a benefit nonetheless. So with that, I would just like to thank a couple people, the California Cattle Council, for funding this work, my co-investigators, Shane DeWeese of UC Santa Barbara, for providing these updated fire behavior models, and Klaus Scott of the California Air Resources Board for helping us a lot with modeling and background resources along the way. And I don't know if I have any time for questions. I'm sorry if I went a little over there, but I welcome questions if there's time. Thank you
No
all.
problem. Yeah, we have about 3 minutes for questions. So if anyone has a question, you can put it in the chat or just unmute yourself and go ahead and ask Felix your question. Or if you're calling on the phone, you can press *6 to unmute yourself. And I know there was one question in the chat that we answered, but it's worth maybe reading it out loud. So the question was this done also with sheep and goat grazing? They have different impacts on forage and different methane emissions from their own enteric fermentation / manure.
That's a really good point. And the answer is no. This was just looking at cattle grazing as sort of the predominant land use of rangelands, the predominant grazing use in California. But it's not to say that those other categories aren't important. And actually, it would be really interesting to do the same, thinking about sheep and thinking about goats, for sure.
Great. Any other questions for Felix? Okay.
All right. Well, thank you all.
Thank you so much, Felix. Really appreciate that update. So now we will transition to talking about prescribed burning, which along with grazing is another way to make our communities safer. So I'm going to briefly talk about a CAL FIRE grant that I received in partnership with the RCD of Monterey County to develop the Central Coast Prescribed Burn Association. So for those of you who are not familiar with prescribed burning, it's the purposeful use of fire, what some people call good fire, to achieve a land management goal. Goals could be anything from reducing fire fuels to cultural burning goals, to increasing forage for livestock, controlling weeds, or improving habitat for native plants and wildlife. Prescribed burns are well planned and are only conducted if conditions on the day of the burn meet what is required by the burn plan. So that means that temperature, wind speeds, relative humidity, and other factors will need to be within a specified safe range. And if any of those factors are not within the specified range or the specified prescription, the burn is postponed. Prescribed burns are often conducted by a certified burn boss, but can also be done by the landowner if the landowner has the appropriate experience. So through the Central Coast Prescribed Burn Association, or through the PBA, we have been doing a bunch of things recently. We have purchased a bunch of prescribed burning tools, like drip torches and hoses and hand tools, other kinds of equipment. And we also purchased a trailer to store all this equipment in. We hired Jared Childress, who is our part-time prescribed burn coordinator, and Jared has been really busy. He has been doing some site visits and planning for people who are interested in prescribed burning. He's coordinating and teaching prescribed burn skills trainings. Sorry, my timer. He's also conducting home hardening and defensible space workshops. And through the grant, we are also going to conduct at least 5 prescribed burns. So the goal of the PBA is to train our members to safely conduct prescribed burns. And also we want to make our PBA members, our equipment, and our technical services available to people who want to burn on their land. So far we have about 375 people who are currently on our PBA email list. And PBA members are ranchers, tribal members, vineyard managers, land management agencies, students, academics, and anyone else really who's interested in prescribed burning. Through the email list, we share information about upcoming events and opportunities related to prescribed burning. And instead of me going on and on, I've asked a few of our PBA members to talk with you today about their background and their participation with the PBA. So first, I'd like to welcome Jeff Popno from the Schmidt Ranch in Bitterwater, which is in southern San Benito County. Jeff is now retired, but spent more than 20 years working for the fire service. And we're really grateful that he's been willing to share his knowledge and experience with all of us through the PBA. So Jeff, do you want to go ahead and share a little bit about what you've been doing with the PBA?
Yes, hello everybody. After that introduction, I don't need to say too much, I guess. Can you hear me okay?
Yep, we can hear you.
Can you hear me, Davey?
I know there's a little bit
Okay,
of a delay,
all right.
but we can hear
So
you.
I'm here to discuss. All right. I'm here to discuss the benefits of using the PBA to conduct a burn on private property. I'm involved with training volunteers in the PBA along with Davey and Jared and several others. So my background is 14 years as a firefighter with the U.S. Forest Service. So not only forests, but also grassland also. And 9 years as a part-time firefighter with the Truckee Fire Department. So I have been on several prescribed burns in the past. So I'll talk a little bit about the past. In the past, it's been very difficult to get burns done. I'm talking locally here, mainly because of the permit system through CAL FIRE, the lack of equipment and the people to help. So the availability of a weather window and to do it, and the length and the severity of the wildland fire seasons. So the busier CAL FIRE is, the less time they have for prescribed burns, right? So I'm looking at my notes here. The PBA can work independently of CAL FIRE to conduct prescribed burns. In the past, ranchers have used heavy equipment to clear brush, but it can be expensive, and some may not own it or be able to rent the machinery to do it. The PBA is new here, but it's a great asset for improving the rangeland. Also clearing away large amounts of vegetation or burning piles such as tree limbs and brush. Okay, so you could say the PBA is a proponent of good fire. So that's the key. We want to promote the group to use fire in a successful way, to improve rangeland, also to create defensible space. So I'll harp on having defensible space for a minute here. Most ranches, and I'm not talking about just ranches. So most ranches have either bare ground or plowed dirt around their structures. So no matter where you live, you should have defensible space around your house. If you haven't started yet, you should start, because if you don't, you're crazy, I think. So anyways, use the PBA to help you burn piles. And I'm sure David can add some more to this, but a little bit of the defensible space, I think most of you know what it is. Especially up in an area that's heavily forested, so we're talking a lot of heavy fuels, so Santa Cruz Mountains, right? Defensible space around your house, there's a lot of different ways to do that. And as far as having the work done, there's a lot of people you can hire out to do it, well, if you can't do it yourself, and then you could use the PBA as a resource. So even though we're young, it's a small organization, it's on its way. They have the equipment, like Davey was already saying, and the means to transport it. And other than that, I don't have a whole lot more. I'm a real proponent of the defensible space, because I think it's pretty obvious that if you have a lot of fire going and you don't have a lot of firefighters, such as engines, aircraft, etc., whose house is going to get saved first? So that one of the key take-home messages. So is it okay to open it up to questions?
Sure. Actually, I think what we'll do is we'll go ahead and go on to our next speaker, go through all our speakers, and then have a few minutes for questions at the end for all of the speakers. So thank you so much, Jeff. I really appreciate that. So next up, we have Sarah
You're
French.
welcome.
Thank you. So next up, we have Sarah French, who is, I believe, the interim executive director for the Amamutsan Land Trust. And the Amamutsan Land Trust has also been involved with the PBA a bit. So Sarah, do you want to talk to us a little bit about your experience?
Thanks, Davey, and hi, everybody. So I work for Amamutsan Land Trust. I'm actually the director of development now, but I do have a history of experience in range management, including range master's degree from UCB. So shout out to all my fellow students out there, alum. And I should just say I'm not a member of the Amamutsan Tribal Band. but have worked with the Land Trust for a long time. So I just want to quickly give some background about who are the Amah Mutsun Tribal Band, why are we involved in this effort, what is Amah Mutsun Land Trust doing? So the Amah Mutsun are a federally unrecognized tribe comprised of around 800 members who trace their ancestry back to the indigenous people taken to Mission Santa Cruz and San Juan Bautista. The tribe survived 3 brutal waves of colonization, which displaced them from ancestral lands and interrupted their indigenous stewardship practices. And today the tribe doesn't own any land, doesn't receive support from the government, but most members live in the Central Valley, which is really far away from their ancestral lands. But still the tribe maintains a sacred obligation to continue on the path of their ancestors and to care for and speak for their ancestral lands. So this is what Amah Mutsun Land Trust was established to do. Essentially, we're a nonprofit organization established in 2013, and we're working to restore access to traditional lands and restore indigenous stewardship practices. Cultural burning and grassland management are 2 really important ones for us. We work within the ancestral lands of the Mutsun and Awaswa speaking peoples. So geographically, we're talking about the area between Año Nuevo Point in the north and Pinnacles National Park in the south. So we work in San Mateo, Santa Cruz, Santa Clara, San Benito, and Monterey counties. And the main way that we implement our work is through our Native Stewardship Corps. The Native Stewardship Corps is a work training and cultural relearning program for tribal members. And our Native stewards are trained as wildland firefighters and as sawyers. And about 1/3 of the work that they do throughout the year is fuel reduction work, prescribed fire, and grassland restoration work. They also propagate native plants, remove invasive species, and do research projects that help the tribe relearn and validate the knowledge of their ancestors. So the Central Coast PBA is helping AMLT meet our goals in a variety of ways. The PBA is providing a venue for the Amah Mutsun to make their perspectives around fire known, and for the tribe to build relationships with other like-minded individuals and groups in the fire world. This is really important for the tribe to be able to speak out, share their perspective, and have a seat at the table. The ancestors of the Amah Mutsun and other California Indian tribes used fire regularly for thousands of years as a resource management tool. And the Amah Mutsun believe that fire is a gift from Creator. It's a critical component in restoring and caring for indigenous cultural resources. And it's not to be feared, it's to be honored and utilized. And others in the PBA also understand fire as a tool and want to see it used. And so together we can promote that vision and support each other in putting good fire back on the ground. So the PBA has provided some really tangible support to AMLT so far, especially in the form of offering fire training to our Native stewards, and also by inviting folks from AMLT to provide training to other PBA members. So there's this knowledge exchange happening. And the PBA has been great for sharing knowledge, sharing opportunities, sending out those emails, letting us know where we can get involved, and also helping identify funding sources that support our shared goals. So this relationship that we're developing around sharing training resources is really an area that we're excited to expand on in the future. There's one grant application pending that, if funded, would provide support for a tribal member to do an immersive 2-year internship with the PBA to learn the skills needed to plan and conduct prescribed burning and eventually become a burn boss. So this would really increase the capacity of our new cultural burning program and move the tribe closer towards their goal of becoming a leader for prescribed burning in their territory. So it's a really exciting opportunity for us. And one day in the future, AMLT would like to run our own fire crew with an engine and all of the qualifications and equipment needed to conduct cultural burning and respond to wildfire incidents within our territory. And we know that relationships like those that we're building within the PBA will be really important for helping us get there. And we're also excited to work closely with others who are using fire as a tool, so that the Indigenous perspective and history is acknowledged, that it's not forgotten, and that it's incorporated into our shared work together. So with that, I will just say thank you, Devii, for inviting us to speak. And thanks for everybody who is contributing to this partnership. It really is valuable to us.
Thank you, Sarah. I appreciate that perspective. We're going to have one more PDA speaker.
I'm muted.
Oh. We're going to have one more PDA speaker talk a little bit about a prescribed burn that we actually, our very first prescribed burn that we conducted through the Central Coast Prescribed Burn Association. So I would like to invite Matthew Timmer to talk a little bit about that burn. He is he's a natural resources specialist with the Land Trust of Santa Cruz County. Matthew, take it away.
All right, can you hear me? Really great stuff. Yeah, hard to follow up on that. There's so much room for collaboration. As a natural resource manager, I manage thousands of acres, and I'm always looking for different tools to manage vegetation and so on our properties. I was exposed to prescribed burning over 20 years ago, and I've been captivated ever since. So I learned about the formation of this, wrote a letter of support, and I've been working with Devii and Jared the last, I guess, over a year and a half to finally get fire on the ground on one of our properties. So I'm going to give a really quick presentation of that. I'm going to share my screen, and hopefully that works. Can you guys see that? Does it say Watsonville Slough Farm Prescribed Burn?
Yep, we can.
All right, excellent. So this summer, we burned a 6-acre restored grassland. This was former ag fields. This is our Watsonville Slough Farm property. It's a 500-acre property in Watsonville. Here's Struve Slough, Watsonville Slough, Harkin Slough, and then this is Hanson Slough. And Lee Road and Harkin Slough Road, just for reference, here's Highway 1. Here's the 6-acre grassland that we burned. And this was one of the burns that was done through the grant. And a burn boss was hired to write the smoke management plan and the prescribed burn plan. And then PBA members were invited to come and participate and work on it. So super cool opportunity. And it happened last month in July. So as I mentioned, the burn was led by a burn boss and carried out by trained volunteers. And I was pretty astounded by the level of training that these people had. Old and young people, male, female, I mean, all different types came out and donned the Nomex suits and grabbed the tools and got to work. Brent's 40 Fire Department wanted live fire training, so they came out to assist with it. And then CAL FIRE was present as standby only. And the reason for this is because we ended up having to do the burn as a VMP burn, and this was all due to liability, and I don't even want to go on about that. But we were able to get fire on the ground, and it was a really good experience for all. If you want to see some live footage, I encourage you to go to YouTube. I posted some videos there. If you just type in the search Watsonville Slough Prescribed Burn, Slough Farm Prescribed Burn, it'll pull up some videos. They're just short 2-minute videos and show some of the action. This burn also allowed some research to be done, very similar to, sounds like, to what Felix was doing. This was some plots that were manipulated to simulate grazing, and then they looked at fire length, flame length, and different things. This is Matthew Shapiro from the UC Co-op Extension. We also had our partner organization, Watsonville Wetlands Watch, conduct pre-burn vegetation sampling to so that we can learn from it, and I can learn from it as a land manager. We'll see what comes up next spring and maybe the following spring, and maybe tailor the next burn differently to get a different result if needed. Here's a cool overhead picture taken with a drone after the fire, and you can see the research plots here. And it was surrounded by great place to burn. It was surrounded by freshwater wetlands and riparian vegetation, dry farm tomatoes. And so a really good place to practice fire. Plus, there were ecological benefits. So outcomes, first of all, the whole event was just carried out so professionally. I was really impressed. Even, down to like having the meeting, the ops meeting before the event happened, and everybody knew where they're going and broke into teams, and everything went super smoothly and safely. And people got experience working with live fire, which I think is really valuable. It's one thing to train on the tools and so on, but another thing to actually work with the fire. The native perennial grasses that are here, the purple needlegrass and meadow barley, I think are all going to benefit, as well as native forbs that have been kind of getting choked up. Our management prior to this has been just annual mowing. So there's some thatch buildup. We overcame some liability challenges and hopefully came up with some solutions that other organizations or landowners can use in the future. And overall, the project helped build local capacity for using good fire, overcoming barriers to controlled burns in our region. Our prescribed burn was relatively simple, but set the stage for a series of increasingly complex projects. So these next 4 or so that are under the grant, I think will become more and more complex, maybe burn in different vegetation types and so on. And it received some really positive press, which I think was great for the PBA. And that's it. These are just, I guess, one last thing. This is 12 days after the burn. I went back to the site and the bunch grasses are already sprouting. This is purple needlegrass. Amazing.
Thank you so much, Matthew. That was a really great slideshow. And it was so cool to see the image of the grass, the perennial grass coming back. What did you say, 12 days after the burn? So that's pretty cool and impressive. I know sometimes people, ask, why are you only burning grassland? That's not, if fire safety is something that you're really going for, shouldn't you be burning other ecosystems? And I just want to acknowledge that perspective. And I think one of the main reasons that we chose this as our first burn was because it was a training burn, first and foremost. There was absolutely the ecological values to it, but we really wanted to train a lot of people who maybe didn't have any experience with prescribed burning in the past. So, and like you mentioned, Matthew, we are going to work our way up. So the next burn that we're going to have is at Santa Lucia Preserve in Carmel Valley in Monterey County. And that's going to be a mixture of grassland and shrublands. And then hopefully, if all goes well, we will eventually do sort of the understory of an oak woodland that's been treated in the past. So I just wanted to make that note as well. So we have about 5 minutes left, and I want to open it up for questions for any of the speakers, whether you have another question for Felix, who spoke earlier, or any of our PDA speakers. I just wanted to open it up for about 5 more minutes of question and answers. I think there was a question in the chat from Larry Ford to Sarah. It says, if the AMLT and other Indigenous people had the opportunity to treat the entire landscape to reduce risks of catastrophic wildfires, what tools other than prescribed burning, for example, grazing, forest thinning, shaded fuel breaks, would you want to use? And what would be your vision for what the long-term conditions of the landscape would look like? That's a big question. Sarah, do you have any thoughts on that or any portion of that?
I'll do my best speaking from my perspective at AMLT. I mean, obviously I can't speak for other Indigenous people and their goals, but what I've heard from the Amamutsan is that treating the landscape to reduce the risk of wildfire is not the primary goal, actually. I mean, really what the tribe is focused on is promoting culturally significant resources. So creating conditions that help their food and medicine and material plants grow because they respond really well to fire. And, an additional outcome of that initial goal is that it does reduce the fuel loads and reduce the risk of wildfire. So there's that. And then just based on what we're doing right now, we recognize that it takes a long time to get to prescribed burning in some ways. Like you really have to prepare the landscape and undo like years and years and years of fuel accumulation before you can get to a point where you're really doing those cultural burns. So right now, what we're really focused on is manual thinning of the landscape, and especially focused on grasslands where shrubs are encroaching, where we know that they, used to be grasslands under California Indian management. There's a greater abundance of cultural resources in grasslands. So that's what we're interested in managing for. So we do a lot of work to remove shrubs from grasslands and thin areas around the grasslands, get rid of dug for forests and stuff so that we can get back to that broadcast burning. Also doing shaded fuel breaks in forest ecosystems really helps to protect like the big oaks and the really mature trees that produce a lot of those cultural resources. So yeah, that's kind of the best answer I have so far. The Amundsen tribal land has not really gotten into grazing as a way to promote cultural resources or move us towards broadcast burning. Not that that's that there's an opposition to that. It's just not something that we've done yet.
Thank you, Sarah. Appreciate that. Does anyone else have any questions for the group? I guess I'll just say that, we're how many fires are going on right now? I'm not even sure how many thousands or hundreds of thousands of acres are burning right now. So I think this is a really pressing topic, and I feel really grateful to be on the side of just learning about what are the issues and how can we help find some solutions. And I think grazing and burning are both tools that we can use in a really targeted way to help make our community safer and achieve other, conservation or, habitat or livestock values, food, all of these other things. So I think this is a really interesting topic, and I think there's lots more work that can be done. I'm really excited about the Prescribed Burn Association as we grow. Like I said, we have about 375 folks on our mailing list. So I look forward to growing the PBA and getting more prescribed burns done in the years to come. So with that, if no one has any more questions, I think we can wrap it up. I'll just one more ask for questions, and if not, we can wrap it up. All right, well, thank you all for taking an hour. Oh, there was maybe one question in here. Oh, no, just thanks.
I do see a question, Devii, about cultural burning versus prescribed burning. I would love to answer that really quickly. Because, prescribed burning, well, I'll just start. Cultural burning is a prescribed burn that happens for cultural values, like I was saying. So we're not necessarily trying to improve, range for livestock or reduce wildfire danger. We're doing a burn for cultural values, so to promote those food, medicine, and material plants. And it's a burn that's done by Indigenous people, so that's another difference. And it includes, it has ceremonial goals as well, and it includes ceremonial aspects. So fire is a really important part of ceremony for the Amundsen and for other California Indian people. So it's not just a fire to achieve resource goals, it's also achieving ceremony and spiritual goals as well.
So I guess we're at 5 o'clock, and I will just read Mark Horney's comment. I think we need to work toward community scale, long-term, continuous land management for fuels. And these are two of the tools for that. So with that, thank you all so much for being here, and we'll see you next time.